Hello viewers, in today's session we are going to discuss a mixed problem on definite integral and limits, right? And here we have to find out the value of this expression, that is limit n tends to infinity and integral from 2n minus 3 to 2n plus 4, and the integrand is x square plus 6 over x square plus 1 and dx, right? So here what we will do, we'll first find out the indefinite integral of x square plus 6 over x square plus 1, and then we'll apply the limits, and then we'll find out the value of the expression when n tends to infinity, right? So let us start. So let us first see the indefinite integral of this function, that is x square plus 6 over x square plus 1, right? So to evaluate this integral, let us separate, or let us write this integral as a sum of two integrals, right? So to write the integral as a sum of two integrals, what we will do, we'll split this 6 as 1 plus 5, right? So we have x square plus 1 plus 5, and here we have x square plus 1 and dx, right? Okay, so now we'll separate this integral at this point, and we'll write x square plus 1 over x square plus 1, and then we have 5 over x square plus 1, and here we have dx. Now these two terms get cancelled, so we have integral 1 plus 5 over x square plus 1, and here we have dx, and now we have integral dx and 5 times the integral 1 over x square plus 1 dx, right? Now the integral dx is x, and here we have the standard result from indefinite integrals. So we have 5 times tan inverse x, right? So the value of this integral, that is 1 over x square plus 1 dx, is equal to tan inverse x, right? Okay, so now let us substitute this value over here. So this expression now reads as limit n tends to infinity, and we have the limits 2n minus 3 to 2n plus 4, and here we'll take the value of this integral as x plus 5 times tan inverse of x, right? So now we'll substitute the limits, and we'll take the difference. So now we can write limit n tends to infinity. First we'll substitute the upper limit. So we have 2n plus 4 plus 5 times tan inverse of 2n plus 4, right? So this is our first term. Then we have here the negative sign, and we have 2n minus 3, and then we have 5 times tan inverse 2n minus 3, right? Okay, now let us combine the similar terms here. So we have limit n tends to infinity, and then we can now combine 2n plus 4 and this term, that is 2n minus 3, right? And then we can combine these two terms. So we have plus 5 times tan inverse 2n plus 4 minus tan inverse 2n minus 3. So now we can write limit n tends to infinity, and here we have 2n plus 4 minus 2n plus 3. So 2n and 2n get cancelled and we are left with 4 plus 3 is 7, and here we have 5 times tan inverse of 2n plus 4 minus tan inverse of 2n minus 3, right? Now we can take the limit here, and we can easily see that when n tends to infinity, then these two terms, that is tan inverse 2n plus 4, it tends to tan inverse infinity, and that is tending to pi by 2, right? Because tan pi by 2 is not defined, that is infinity, right? So tan inverse infinity is equal to pi by 2. So when n tends to infinity, then 2n plus 4, it tends to infinity, right? And similar is the case with this term. So tan inverse 2n minus 3 also tends to tan inverse infinity, which tends to pi by 2, because when n tends to infinity, 2n minus 3 tends to infinity. So now this expression has the value, here we have 7, and then we have 5 times tan inverse 2n plus 4. So tan inverse 2n plus 4, it tends to pi by 2. So here we have pi by 2, and similarly tan inverse 2n minus 3 also tends to pi by 2. And here we have a negative sign. So this is pi by 2. Right now, pi by 2 minus pi by 2 is 0. So we have 7 plus 5 times 0, that is 7 plus 0 is equal to 7, right? So the value of this expression is equal to 7.